In this lecture, we are going to see some hands-on example for unsafe consumption of APIs vulnerability in our application. We're going to focus on our about page in our user interface, in our application front end, where a user can enter its email ID and then subscribe to my application. Now, unsafe consumption of APIs is all about consuming third-party APIs in an unsafe manner. So for this purpose, I have created a mock API endpoint using typecode.com, which basically you can create a GitHub repository. I've created one in my org with the name third party API, and then add a db.json file in it with a JSON structure, right? So here I have created a mock API endpoint for users where users can provide email IDs. It will generate an ID for you and store your email ID. So once you create this repository with db.json file in it, typecode by default will pick this file and convert it into mock crude API endpoints for get, post, put, and delete, right? Something like this. Now you can go here and see here, it's my repository name. Sorry, this one. So this is my user repository name, and then the users in that db.json file, right? Similarly, you can copy it and add more endpoints for different entities, as many as you like. We just need one, and when you do a get request or post request to this endpoint, you will get back a response, right? So here I'm doing a get call, so I simply got back my entry that I made here. So this is like a third-party API, and we are going to use this endpoint as example to make post calls to this mock endpoint from our code. So let's go back to our user interface. So this is our about page in our application. Here I can enter my email ID and subscribe to this portal, right? So before we go ahead and try this out, let's see what's happening in our React code or front-end code. So inside my client folder where my React or front-end code resides, I'm going to the about.jsx component, which basically composes my about page. Now here you can see, if you scroll down, so this is what's getting rendered on my application in that about page. Now here you can see that once user enters the email ID and clicks on submit, handle submit method gets called. Now in this method we are simply taking in the email ID, right, and then calling this add subscribe method. Let's go to this method, and we are passing the email ID as is that user enters in that text field. Now in this method we are simply using Axios. So HTTP service is nothing but I'm using Axios here, which we can use to make get, post, put, and different API calls, right? So this is just Axios service instance. I'm making a post call, and here I'm passing the email ID as body and making a request to the third-party API, right, which we just saw hosted at typecode. So here also you can see in my config.json file, third-party API endpoint is nothing but the same API endpoint, the mock one that we just created in typecode, right? Now the important thing to note here is that our code is using a third-party API, right? And we are not doing any kind of sanitization or validation to what's going to this API and what's coming back, right? So once we make this post call with our email ID that user enters, whatever this API returns, the third-party API gets returned to user as is. We're not making any validation or sanitization of data here, right? So let's go to our UI. Now let's take an example where it's a normal user, not a hacker, and it goes in and enters, let's say user1, its email ID to gmail.com, and click on subscribe. So this is a valid email address, right? Let's see what happens. So my front end sends the request directly to the third party API, right? And if you see the payload, it's just the email ID being forwarded to third party API as is without any sanitization and validation. And in response, we get back a JSON file where it's again email ID and ID. So this is fine, right? If it's a normal user, not a hacker, not trying to do anything malicious with the system, it works fine. But what if I try to inject some XSS or cross-site script in this text box? So let's see what happens. So let's see I try to inject here something like this, right? So this is a very typical example of XSS script, right? I'm trying to add a marquee, a JavaScript marquee with some emoticon here, right? So let's see what happens if I try to enter this data in email and click enter. So you can see that this is a very simple example. I have just kind of hacked my front-end code, but if you look at the API call, the payload sent to my third-party API was something like this. So instead of email, I sent a malicious payload, and then the API gave me some malicious payload back, right? Now imagine a scenario where your application gets back something like this, a malicious payload back from third-party API, because hacker was able to compromise this API endpoint, the third-party API endpoint, and then you just simply store this data back in your database, right? And the hacker can then use this stored malicious data in your database or system to further compromise the security of your application, right? You can see more example of this. There is another typical example of cross-site scripting injection here, and there you go. Again, your third-party API does not do any check, it's compromised, and you get back this data from third-party API, save it in your system, and that's it, your system is compromised. So to mitigate this issue of unsafe consumption of third-party APIs or APIs, we need to always validate what's going in your system and what's coming back from third-party APIs before further processing these data items. So in our code, you can do checks like, validate that it's a valid email ID here. You can use regex patterns check here, and then whatever comes back, instead of returning it directly, you can save it as a response, and then before returning the data back, the response back, you run some validate function to validate your response, right? So this validate function will kind of validate the expected response format and data in it, right, before further processing it. To mitigate this issue of unsafe consumption of APIs, you can always take some precautions and follow best practices, like always assess the API security posture of service providers. So whenever you use third-party APIs, just make sure they are safe and secure at the provider level, and also that you are using it in a secure manner. Always ensure all API interactions happen over a secure communication channel, TLS, transport layer security should be implemented properly so that all to and fro data to this third-party API is encrypted. Now, validate and sanitize the data received from integrated APIs before using it. We just saw this in our example. Maintain and allow list of well-known locations integrated APIs may redirect to, and avoid blindly following redirects. So let's say in case, as we discussed earlier as example, somebody tries to hack the third-party APIs to redirect your request to their own servers or wherever they want to using 308 permanent redirect. So if you put a allow list of well-known locations where integrated APIs may redirect to, that issue can be mitigated. So this was all about unsafe consumption of APIs, and we have covered all the 10 OWASP API security vulnerabilities of 2023. I hope this course enhanced your knowledge a little bit in this field of API securities. Thank you.